Hey guys, so in this video we're going to go over how to make epoxides from alkenes. Okay, so this is a very common method using a very common compound as a reagent. We're going to be using this thing called mCPBA. So mCPBA is obviously an acronym. mCPBA. It's an acronym for metacholorperbenzoic acid. And this molecule looks just like this. You have a benzene ring, hence the benzoic part. You have a chlorine in this position, in the meta position, compared to their functional group over here. This isn't that important, but just, it's good to know. And because we're actually going to go over the mechanism for this problem, and I'm going to be using this problem a lot, I'm going to shorten it a little bit. This section right here, I'm just going to call an R group, because it's not that important to the actual mechanism part. Okay, so R, you have this double bond over here, you have this O, and this O. Okay, so how does this mechanism work? So I'm just going to redraw this molecule over here. R, double bond O, and then an H. Okay, so the first thing that's going to happen is this. I'm going to draw all the electron pushing in red. This alkene is going to come and attack this oxygen right here. Okay, this is the most easily attackable oxygen, I guess. It has the least defenses around it, I guess, right? If you look at this oxygen right here, it has this big group on the left, and this oxygen, which is a pretty big molecule on the right. So it's pretty shielded. This oxygen is the most vulnerable to attack. Okay, so once that happens, that's going to be getting attacked. Then this bond is going to go ahead and break over here. This bond is going to break and come onto this carbon over here, right here. Okay, hence our epoxide bonds right here. These two arrow pushes are going to make our epoxide bond over here. This bond and this bond. Okay, but then after that, there's some problems that obviously arise. We have this hydrogen floating in space, which is going to be taken care of soon, and we also have this this bond being broken from this oxygen. So what's going to happen is this bond over here is going to come and make a double bond there, and then I know what you're thinking. How could that be possible? If I have a double bond here and a double bond here and a single bond here, that's 5 bonds to a carbon. That's pentavalent carbon. That's not possible. And you're right. So what's going to happen is one of these bonds is going to come. Oops, bad line. One of these bonds is going to come and grab that lonely hydrogen, because it was pretty lonely, right? We took that bond away from it, so it was by itself. So that's those are the 4 arrow pushing steps you have to understand. Technically, some of these arrow pushes are a little bit misleading, because over here, for example, and this isn't too important, but just so we have our first principles down, what's really happening is we're taking our double bonds, our electrons, into a lone pair here, and then from there it's being taken into this bond. But that's really not that important. The idea is at the end it's going to go from this bond into this bond. Okay, so this is all you have to know for now. So once that happens, let's go ahead and draw it on the side. Once that happens, you're going to have a single bond here, right? This, I'm going to start drawing it in interesting colors so that's easier to see. This arrow pushing reaction right here is going to result in this thing right here. Let's figure out some more colors we can use. Let's go with purple. This arrow pushing mechanism right here is going to result in this bond. Okay, and then this forms our epoxide, right? So this part's done. So this part is all taken care of right here. This part over here is what made this epoxide. But then what happens to the rest of this stuff? Like, essentially, what is the byproduct? Obviously, our goal here was to make an epoxide, hence the title of this video. But there's still some byproducts which are also very important, okay? So the byproduct is right over here. So we still have this R group over here, so I'm going to draw that in, let's draw our byproduct in green. I still have my R group over here. I still have this carbon that was untouched, but now instead of this being the double bond, this is a double bond, right? So I have a double bond here, and I have this O. Then this oxygen right here is now a single bond but again, this bond that it had broke and grabbed that hydrogen. So I'm gonna have an alcohol up there, an OH. And this is our side product. And this is our epoxide. So yeah, it's not that complicated of a mechanism, but this part can be pretty confusing, especially the way that I drew it over here. I'd suggest going back from where I drew all these lines if you want to copy down the mechanism back to that original step. But yeah, this is pretty simple. It's important to know what mCPBA is because the actual structure of it helps understand how this happened. And just make sure you have your arrow pushing in line. And it sometimes doesn't make much sense. It's kind of confusing, but when you actually think about it, as long as the electrons are going to the right places, you're good to go. Okay, and we started off neutral. We ended up neutral, so we didn't add any extra things or take away any unnecessary things. So this reaction is pretty complicated, but as long as you do it slowly, you can go ahead and take care of it. All right, guys, thanks for watching, and I'll see you in the next video.